Hi everyone. Well, this is a very quick video talking about hyperbolas. And a hyperbola is a polynomial with x and y where both x and y are raised to the second power and we have a different subtraction between them. And instead of saying in words, let's look at it. X squared minus a squared minus y squared minus b. X squared divided by a squared minus y squared divided by b squared equals 1. So this is a standard position. Now, this example I have is not in standard position. I have 9x squared minus 4y squared equals 36. I can still recognize that it's a parabola because x is raised to the second power, y is raised to the second power, and between them I have subtraction, so I have a difference. Now, you can do this problem sketching without putting this in the standard position. I start calling it standard form. But I'm going to go ahead and put this in standard form. Now, when I do this, I am going to tell you how to do some things without explaining it. So that's, would be a longer and, less, it'd be a longer video if I explain some of this, all those things. But especially, I'm going to look at some asymptotes, and I'm not going to talk about that. There's other things on hyperbolas I'm not going to talk about. But the first thing I'm going to do here is I'm going to divide everything by 36. Why 36? Because that's what's on the right-hand side of this equation we're given. And when I divide by 36, then what happens is I get 1 on the right-hand side, and that takes me towards this form here, this standard position form. So, all right. But really, to get it exactly like that same form, I'll have x squared over 2 squared minus y squared over 3 squared equals 1. And once it's in standard form, what we can do is we can focus on these numbers here. 2, I guess, would correspond to being A, and then 3 would correspond to being B from that standard position form. And so, okay, let me tell you how it's done for this guy here. And it's a little bit like I'm going to just say how to do it without explaining all of it. So what we're going to do is we're going to look at those numbers 2 and 3. And what I do is with a 2, I go along the x-axis till I get 2, 0 to the right, and then 2 to the left, and I get negative 2, 0. For the 3, I go up by 3 and get 0, 3, and down by 3 and I get 0, negative 3. Now what I'm going to tell you though is actually the points 2, 0 and negative 2, 0 are points on the graph. And I can see that by letting y equal 0. If I let y equal 0, let's just do this maybe over here. I don't think I need to do this, but I'll just do it anyway. Let y equal 0. If it's in standard form, I don't need to do this step. I can just sort of figure it out by what I'm showing here. But look, if you set y equals 0, I get x squared over 2 squared equals 1. So x squared equals 2 squared. So x equals plus or minus 2. So we have x-intercepts 2, 0, negative 2, 0. Notice if I make x equals 0, I get negative y squared over 3 squared equals 1. If x equals 0, I get negative y squared over 3 squared equals 1. That means there's no solution because setting x equals 0 leads to the equation y squared equals negative 3 squared. So x equals 0, I get negative y squared over 3 squared equals 1. Y squared equals negative 3 squared. And there's no real solution to that. So there is no y-intercept for this guy. There's no y-intercept. So actually, I started going on a little bit more than I thought I would. But anyway, there's no y-intercept for this guy. Okay, so why would I then plot 0, 3 and 0, negative 3? Well, what I'm going to do is I'm going to make this little rectangle here. And I don't want to have it colored in though. I want the fill to be nothing. Okay, I have this little rectangle and the vertices are given by plus or minus 2, comma, plus or minus 3. Okay, so the vertices are related to the 2 and the 3. And then what I'm going to do is I'm going to draw straight lines, draw lines through the vertices of that rectangle. Oh my gosh. Okay, so you can do some pretty fun things with the program, but this program on the iPad, it's Notability, but sometimes it can be frustrating. iPad is good for making these videos. Before I had this, videos were much more difficult. So, all right, there we go. Okay. Yeah, we need everybody to be able to afford an iPad or something, all the kids around the world. Somehow. Okay, maybe not. Pencil and paper is also super good. Even better, maybe. Okay, let me just tell you how this works. These guys are asymptotes. And so one of the things you might ask to do to just get a super good picture is to find the asymptotes. And the asymptotes are these lines here where they're lines that pass through the vertices of a rectangle. Okay, I can look at this because I have the 3 and the 2 and see that I have the asymptotes 3 halves x, and those are lines, y equals 3 halves x, half x, and y equals negative 3 halves x. How can I do that so quickly? These lines pass through the origin. So if I'm thinking y equals mx plus b is my form of a line, the y-intercept b is 0. So there's no b anymore. So it's y equals mx. How do I find the slope m? I do the old rise over run. See, I'm going up by 3, up 3 over 2. That's 3 halves. That's how I'm getting the asymptotes. Now, that's sort of like, depends on how much your teacher or whoever, how good of a graph you want. Now I'm going to color this in. And like I said, 2, 0, and 0, negative 2, not just said, I showed that I have those x-intercepts, but the graph looks like this. I mean, how would you know this? Well, you would plot more points and you do a bunch of theory and spend a bunch of time on hyperbolas. I'm telling you, this is what it looks like. It follows, because of that box that we drew and those asymptotes with the x, that's how it follows. That's how it looks. And so this goes along with what we have over here. Let's make that even wider and brighter and bolder. No, maybe not. Okay, let me just stick with the colors we had before there. But there we go. So that's what we have there. We have this. That's this graph, and that's the hyperbola. So let me just make sure I write that down. This is hyperbola. Now, what I'm going to do is I'm going to cut and paste this and recycle all this stuff for my next problem. This is x squared divided by 2 squared minus y squared divided by 3 squared equals 1. If we turn it around, and get y squared over 3 squared minus x squared over 2 squared equals 1, then, well, let's do it. How does that look any different? So I'm going to then go back and erase a lot of this junk. All this junk and trash here. Oh, hold on. I didn't center this very well. Let me get this exactly, or maybe not exactly, but pretty close, way better. Okay. So now how does this look? What's the difference here? Okay. Now it looks almost the same, but not quite. What's the same? The box is the same. But this time, if I set x equals 0, I get y equals plus or minus 3 is on the graph. Oh, the asymptotes are the same. Okay, so actually, let me just get rid of those guys there and draw the box again. Okay, here's the box. And what I see is that if I let x equal 0, I get y squared divided by 3 squared minus 0 squared over 2 squared equals 1. So y squared over 3 squared equals 1. Y squared equals 3 squared. Y equals plus or minus 3. So I have y-intercepts 0 plus or minus 3. So here's these two intercepts this time. Should I show it? But if I let y equals 0, this implies x squared equals negative 2 squared, no solution. I know I shortened that and didn't show the steps. But look, if y squared equals 0, you get negative x squared over 2 squared equals 1. That leads to x squared equals negative 2 squared. Okay, and so there's no solutions. In other words, there are no x-intercepts. When I set y equals 0, that's how I find the x-intercepts. There's none. There's no x-intercepts. And actually, the parabola looks like this. So I say parabola, that was totally wrong. Hyperbola. The hyperbola looks like this. Okay, so if you have y squared minus x squared equals 1 with some numbers, as we see, then if it's y squared first, and that difference, it opens along the y-axis. If it's x squared minus y squared, if x squared comes first, it opens along the x-axis. Notice the box is the same. That's sort of interesting, but the box will be the same. All right, there's more on hyperbolas. There's a lot more, but this is like a quick and fast way to do this. And I'm going to try to convince you, you don't even have to write down as nearly as much stuff. Once you get it in this standard form, then you pick the 3 and the 2 and you make the box, make the x's, and then you can easily draw the hyperbola. And some people say, you're making too much of a perfect picture. I'm not saying it's perfect, but maybe I'm overdoing it. Maybe some people say, oh, the big thing I want to notice is that it opens up along the y-axis or the x-axis. And a quick check is to see which axis it opens up is to find intercepts. Like I said, x equals 0 gives y equals plus or minus 3. So we do have y-intercepts. Set x equals 0, find the y-intercept. That's a strong, that tells me that it opens up along the y-axis. The one before, if I set y equals 0, I get x is plus or minus 2. That tells me it opens up along the x-axis. Okay, so that's that. Thank you and goodbye.